Hello viewers, in today's session we are going to discuss a very important and conceptual problem from limits. And here we are going to find out the right hand limit and the left hand limit for this function f of x, that is equal to a sine of fractional part of x divided by a fractional part of x when x tends to 0. So here the curly brackets represent the fractional part function. So let us see how we can find out the right hand limit and the left hand limit when x tends to 0 for this function f of x using the definition of fractional part function in terms of greatest integer function. So let us start. So now the notation for the right hand limit is given by a limit, and here we have x tends to 0, and here we put a positive sign, and here we have f of x. So this is the notation for the right hand limit. So here we have a limit x tends to 0, a positive, and for f of x we can now write here sine of fractional part of x divided by fractional part of x. Now to get the right hand limit, let us make this substitution, that is x is equal to 0 plus h. So here our point is that is x tending to 0, right? So here we have x is equal to 0. So when we find out the right hand limit, then we approach towards x is equal to 0 from the right of x is equal to 0, that is from all values of x which are greater than 0, right? And here we have a point that is in the right neighborhood of x is equal to 0, and this point is 0 plus h, right? And when we find out the left hand limit, we approach towards x is equal to 0 from the left of x is equal to 0, that is from all values of x which are less than 0. And we have a point here that is in the left neighborhood of x is equal to 0. So this point is 0 minus h, and this point is 0 plus h. So here we can now write 0 minus h, and this point is 0 plus h. And remember, h is greater than 0, that is it is a positive quantity, and it is infinitesimally very small, and it lies between a 0 and 1. So when we take x is equal to 0 plus h, then we have x is equal to h, and when x tends to a 0, then h also tends to 0. So now we can write this limit in terms of h. So we have limit h tends to 0, and here we have sine of a fractional part of h divided by a fractional part of h. So now to proceed further, here we have to first simplify this fractional part function, right? So the definition of fractional part function is given by fractional part of x is x minus greatest integer of x, and here we have a fractional part of h. So fractional part of h can be written as h minus greatest integer of h, right? So here when we calculate this limit, we cannot directly substitute h is equal to 0. First we have to simplify, or we have to assign a value to this fractional part of h. So fractional part of h can be written as h minus greatest integer of h. Now see, h is infinitesimally very small, and h lies between 0 and 1. So when h lies between 0 and 1, then greatest integer of h is equal to 0 by definition of greatest integer function. So here we have 0. So fractional part of h is h minus 0, that is equal to h. So now we can write this limit as limit h tends to 0, and here we have a sign of h, because fractional part of h is equal to h, and here we have h. Now this is a standard result in limits, that is limit theta tends to 0, sine theta over theta is equal to 1. So the value of this limit is equal to 1. So the right hand limit of this function f of x when x approaches to 0 is equal to 1. So we can now write the right hand limit as 1. So now let us calculate the left hand limit. So the notation for left hand limit is given by limit x tends to 0, and here we put a negative sign, and here we have f of x. So now we have limit x tends to 0 minus, and f of x is given by a sign of fractional part of x divided by fractional part of x. Now to calculate the left hand limit, will make use of this substitution, that is x is equal to 0 minus h, that is minus h. And when x tends to 0, then we have here h tending to 0. So now we can write here a limit, and x tends to 0 minus is h tends to 0, and we have sign of fractional part of minus h divided by fractional part of minus h, because here x is 0 minus h, that is minus h. So taking x is equal to minus h. So now to calculate this limit, will again make use of the definition of fractional part function. So here using this definition, fractional part of minus h can be defined as minus h, and here we have minus greatest integer of minus h, right? And here we have to now write the value of greatest integer of minus h. So greatest integer of minus h is equal to minus 1, because see, h is infinitesimally very small, and h lies between a 0 and a 1. So if we multiply this inequality throughout by minus 1, then here we have 0, here we have minus h, and here we have minus 1, and the direction of the inequality, it gets reversed, right? So minus h is greater than minus 1 but less than 0. So the greatest integer of minus h should be equal to minus 1 due to the definition of greatest integer function. So here we have minus 1, so we have minus h minus, and here we have minus 1. So this is minus h plus 1, that is equal to 1 minus h. So replacing the fractional part of minus h by 1 minus h, here we have limit h tends to 0, and we have sign of here we have 1 minus h divided by 1 minus h. So now we can take h is equal to 0. So we have here the value of this limit as sine 1 minus 0 divided by 1 minus 0. That is equal to sine 1 over 1, that is equal to sine 1, right? So here the left hand limit of this function f of x when x approaches to 0 is equal to sine 1, right? And here 1 is in radians, right? So here we have now arrived at the conclusion that the right hand limit and the left hand limit both exist, and they are finite, but they are not equal to each other, right? That is, one is not equal to a sine 1, right? So we can claim that the limit of this function f of x when x tends to 0, it does not exist. because for the existence of the limit of a function at a given point in its domain, the right hand limit and the left hand limit both should be finite, and they should exist, and moreover they should be equal to each other. But in this case, although the right hand limit and the left hand limit both exist and they are finite, but they are not equal to each other. Hence we can claim that the limit of this function when x approaches to 0, it doesn't exist.